Today we are going to learn how to use a multimeter. Okay, this is a multimeter that we will be using for most of our measurement and measurement through our projects, etc, etc. It is a Digitech QM1323. Now I'll just pan in, just come in on the scales so that you can see what scales we've got there. Okay, if you notice we have a temperature scale on the left hand side followed by an HZ percent scale, which is hertz or cycles per second. Hertz means cycles per second, but we'll get to that later. Then we have an ohms, diode, beep and capacitance range, and then we have a voltage range, voltage AC and DC. The center obviously off button, and then to the right hand side we have the current range. First of all 10 amps, then milliamps, thousandths of an amp, and then microamps, which is millionths of an amp. Now I'll just go up and show you the other buttons there before the display. Okay, we have a mode button, basically switching between modes, i.e. on the ohms, diode, beep, capacitance range. We can switch between those modes using that button. And next to that we have the range button. Most of these work on an auto range, so in other words, if you get a measure of voltage or basically a voltage that is higher than the voltage range you're on, it will switch over automatically to accommodate for that voltage range, as opposed to the old multimeters, let's say the analog meters, the meters with a needle, that if you measured say 100 volts on a 5 volt range, you'd probably damage the meter. Then we have a hold button next to the range. The hold button is for taking a measurement. So say you can't look at the screen and you've got to get into a tight spot with the probes, you take a measurement, then it will beep telling you that it's got that measurement. Then you can look back at the screen and see what measurement you took. Okay, the rel button. Now the rel button is used for taking say 2 sets of measurements. You want to know first your relative measurement as opposed to a measurement that you've already taken. So in other words, I measure a voltage, let's say that voltage is 5 volts. I press the rel button once the screen has stabilized. It will then clear the screen to 0. Then I can take another voltage measurement, say 8 volts, and coming up on the screen should produce the reading of positive 3 volts. 8 volts with respect or relative to 5 volts is positive 3 volts. If I was to take the same measurement, I'd 5 volt measurement, and then I was to measure 2 volts after hitting the relative button to store the 5 volts, I would then come up with a screen value of minus 3 volts relative to the original 5 volts that we stored. So it's just ways of comparing 2 measurements, and that's the rel button. Okay, time to take some measurements. First of all, let's measure temperature. So we'll come down to the temperature scale. As you can see, this is say 0 degrees Celsius. We plug our probe in, and almost instantly we get 31.3 degrees. Now I do have a 500 watt halogen lamp over my shoulder here so I can light the bench up. If I touch the sensor with my finger, I should get warmer. So going up, climbing, okay, and then I let it go and it drops down again. Okay, now the next measurement I'm going to take, which I won't put on the camera, but I'll just take the measurement off screen. You can see the effects of it on the multimeter, will be a hertz measurement, in other words a frequency measurement. Now, due to the supply of power in Australia, we basically get 240 volts AC, which is alternating current. We'll go into that a little bit later also, but it is supplied at 50 hertz, in other words 50 cycles a second. Cycle being a sine wave, a sinusoidal waveform, which again we'll show you later. But to test this hertz scale, I'm going to plug the two probes into a 240 volt power socket to get a reading. Put that there. And it's just a little bit loose, but there, and you can see it's 50 hertz. It's jumping between 49 to 50 hertz. Okay, 49.87 hertz, meaning 50 times a second. The connection just went loose, but that's alright. There it is there, 50 hertz. Now I'll just take those probes out. It's very important when taking measurements. These are the probes that we're using. Okay, we do not want to put our fingers onto the actual metalwork as we're taking any measurements. If we do this, we will upset the measurements we're taking and possibly electrocute ourselves at the same time. So we don't wish to take any measurements while our fingers are touching the metalwork of the probes. Yeah, where are they? There we go. I'll just pan back out again. There we go. Okay, so they are the probes that we use for taking measurements. As you can see, they're fully insulated except for this last bit sticking out the end that takes the actual measurement. Right, put those aside for a second, recenter the multimeter, zoom in again. Oh, wrong way, wrong way. Okay, now we're up to the volts, sorry, the ohms, the diode and the capacitance range. Okay, next we're going to measure a capacitor. Now the capacitor we're measuring is what they call a green cap. It's a bit hard to get that on there. It's a green cap obviously because it's green. Now the writing on the side of the capacitor is 103, which equates to 0.01 microfarad, or as we'll see when we take the measurement, looking at the screen, 10 nanofarad. Now nanofarad is to the power of 9, so it's 9 zeros for a nanofarad. Okay, so 10 nanofarad is 0.01 microfarad, but again we'll get to that later. Okay, now the next measurement we're going to make is an ohms measurement. So we're going to measure resistance now. So if I take this rather large looking brick, it is a 5 watt 10 ohm resistor, 1 OR 10 ohm resistor. So if I put it there and again take the measurement without blocking the camera, go. .1 ohms. Okay, that's just jumping around because I'm trying to keep it still. It's auto ranging 10 ohms right there. Okay, so that's 10 ohms.